To solve this trig equation, we need to first solve for the sine squared. So I'm just going to rearrange this equation, and I'm going to isolate the sine squared. So first of all, I'm going to move the 4 sine squared to the other side. And then I'm going to divide both sides by 4. So I've now solved for the sine squared. And then I need to undo the square with the square root. But when I do this, so I end up with sine x, I have to remember that I'm going to get a plus and minus for this. And since square root of 4 is 2, this becomes plus minus square root square root 3 over 2. And that represents a special triangle. Okay, root 3 over 2 is going to be from our 30-60 triangle. So if I draw my 30-60 triangle here, remembering my side lengths, okay, so this is going to be root 3 is a long straight side, 1 and 2 is the long side of that triangle. So then solving this in my circle, I need to solve for the angle x. So I need to undo the sign. So I'm going to use my circle to undo the sign. So root 3 over 2, the positive, which I'll do in a different color, the positive is going to be in quadrants 2 and 1. Okay, so there's going to be my root 3 over 2, my positive version of that. Okay, so the x is going to be, I'm going to write this x1, is going to be equal to the 60 degree or pi over 3. And my theta 2 is going to be the pi minus pi over 3, so 2 pi over 3. So it's a mirror image across the y-axis. We also have to worry about the negative version of this. So the negative version is going to be down here in quadrants 3 and 4. Okay, so we have negative root 3 over 2, negative root 3 over 2, and those angles, so I'm going to call that x3, that's going to be at 4 pi over 3 in quadrant 3, and x4 is going to be the quadrant 4 angle, and that's going to be 5 pi over 3. Okay, so those are my angles, and since it's between 0 and 2 pi, I have one full solution, and I know my period in this case is going to be pi over 2. So because my coefficient is 1, my period is 2 pi. And so I know that that represents one full period of solutions, which is the same domain as that which was given.